traveling from host, which is 192.168.50.126 to host 192.168.55. Here we have topology of three routers, R1, R2, and R3. And it is clear /26 /30 /26 /26, and here we have the prefixes or CIDR for each network. 192.168.50.126 belongs to the network router 3. Here 192.168.50.64, because here 126 within this range of network. The other one, the destination, which is 55, this one, this interface, because this one 54/30, it means 54 the network and the interface .5 and interface .6. It means router 3 will try to reach this interface from R3 to R1. The question is, which path will follow to reach the destination .5 from R3 to R1? Is it this path directly to the R1, or via R2 then R1 to this interface? Let us look to the routing table by the command show IP route. Here show IP route show the connected paths, directly connected interfaces, which is denoted by C, 3 connections for R3, 1, 2, 3 directly connected interfaces, and another 3 here, D, for OSPF. How we can notice the router, this routing information related for the D exactly related to RIP or OSPF? Here directly we can go to the information which is related to the first part here. The first part 990 means this is the AD for OSPF. If the number 120, it means this part related to RIP. But here we have 90. It means the routing process between these routers uses OSPF instead of RIP. And this number related to the bandwidth or the metric as a number, because OSPF basically use bandwidth for routing process or for its shortest path selection or metric. Again, we have 90 for these 3 entries related to the RIP D symbol. It means these 3 routes, these 3 entries uses RIP, with the competition أو المنافسة بالباندويث بين الطرق لنفس النتورك أو لنفس الديستنيشن إذا كان هناك نفس الديستنيشن. So the competition between the entries, if the destination is the same, will depends on the cost or bandwidth. This is why if we follow the steps if we explain the question, we should first looking for the IP address. This IP address belongs to which device or which network. Directly we go to router 3 because within the range of the LAN of router 3. 50.126 here, 50.64 the network. The next network here 64. The next network here 128. It means before the next network 128, 126, it means here. Depends on the block size, as we explained before the subnetting and its calculations. So the source within this network, the destination within this network. It means here the interface part, which is 55, the destination. Then the answer or the question itself, in the network diagram above, which path will packets take when traveling from this host to this host? The choices: packets will travel from R3, router 3 to R2 to R1. It means it will follow from R3 to R2 to R1, R3 to R2 to R1. This is the longest path. This is the wrong choice because two links or two hubs to reach the destination with the cost. The next choice, which is packets will travel from R1 to R3 to R2. Here the choice starting from here. The starting point is wrong because the starting should be from here. This is the wrong choice. We should start from R3. R3, R3. We have three possible solutions which is started by R3. We will omit this one and this one. يعني نختار الحلول اللي تبتدي بالار 3 ك starting point حسب السؤال، لأنه هذا يتبع الهوست التابع إلى الار 3. لازم يبتدي الحل بالار 3 وحسب الحل المناسب بالخط أو الطريق المختصر أو الأقل كلفة بالاو اس بي يعتمد على الكوست. أي طريق أقل كوست ككلفة يكون مفضل على الآخرين. إذن the promoted choices either one which is started by R3 or the third one which is started by R3 or the fourth one which is started by R3. Let us describe each one. This one not suitable because this is the longest path, R3, R2, R1. The second choice, R3 to R1 and return back to R3. R3 directly to R1 and return back to R3. This good solution or the shortest solution. One node and consider the cost. The third and final possible solution, which is started from R3 to R1, this one, the same solution, but the wrong part from the solution, and from R3 to R2 to R1. This part the same like this part, which is already negotiated and wrong choice. Then the only possible and right solution is packets will travel from R3 to R1 and return back to R3. Packets travel from R3 to R1, then return back from R3 to from R1 to R3. So the right solution is the third one. What are the three classes of routing protocols or routing in general؟ ما هي أنواع الراوتينج بصورة عامة؟ Three classes of routing protocols are either distance vector, link state, or hybrid. It means أما نعتمد على distance vector مثل الريب أو link state مثل OSPF أو mixing خليط أو hybrid بين الاثنين. A distance vector routing protocol finds the best path to a remote network by using the relative distance. It means a distance vector uses distance or number of hops like RIP. Each time when a packet passes through a router is referred to or referred as a hop. Hop here means router. The best route is the route or the route which has the lowest number of hops to the network. It means the shortest path here depends on number of hops to the network. RIP and EIGRP are the examples of the distance vector routing protocol. Two examples uses distance vector, RIP and EIGRP. Link state, it's also known as shortest path first, in which each router creates three separate tables. It means it creates like database contains of three tables. Each table performs its different functions, such as one keeps track of directly attached neighbors. The second one determines the topology of the entire network, and the third one is used for the routing table. Here the database, which includes three separate tables, each one responsible for a certain task. One for neighbors, and the other one for topology, and the third one for the routing table itself. OSPF is an example of link state routing protocols. إذن اللينك ستيت يبني أو يحتاج ثلاث جداول كداتا ستراكشر أو داتابيس، يضم ثلاث جداول، كل جدول واحد له علاقة بالنيبرز الراوترات الجيران، والثاني له علاقة بالشكل الشبكة، يهتم بشكل الشبكة أو حاليا وضعها الربط لها اللوجيكال، والآخر يهتم بمعلومات الراوتينج تيبل أسوة ببقية الراوتينج تايبس. Hybrid uses characteristics of distance vector and link state such as EIGRP. هنا ال EIGRP جمع. EIGRP mixes the characteristics of link state and distance vector. مزج الادفانتجز أو الخصائص للديستانس فيكتور واللينك state together in one routing protocol called EIGRP.